Right, grand. So thanks everybody for coming. I realise I'm the last thing between you and Brian, so I will absolutely try to keep this on time. Noting that this is the technical track, I never know how deeply technical to make things. So obviously the slides are not so, but stop me and buy one, as they say. If you want to ask questions, just do that, and we can dig into whatever you actually want to dig into. And yeah, that's about it. So. Kind of engineering heavy. The last one was more sort of math consensus heavy. This is more of an engineering talk, but again, it's about a thing we've actually built. So any detail you want, I probably know it, and we can go down that track. So why pluggable blockchains? Those of you who've been around Hyperledger for a while will know that pluggable consensus is a big deal. It's a thing that we try to achieve, and the reason why you might want to have pluggable consensus algorithms because different consensus is good for different things. I argue that in some cases, for some reasons, you might have to actually plug your entire framework if you're actually going to be able to build a business right now in this day and age. Why is that? Well, there you go. Blockchain concepts, technology, software, whatever, does not necessarily play well with others. Hyperledger is the home of enterprise blockchain, so it says. I realize the website changes every now and again, but fundamentally, it's what we're trying to do is to bring enterprise-friendly versions of distributed, decentralized technologies into the market, and that means that it ought to be enterprise-friendly, but in a number of ways, it isn't. It's kind of confusing, it's very different, it's hard for people to get their heads around, and so it's hard to adopt. And I'm not here to be a skeptic or say that adoption is bad. I'm the kind of guy who likes the Deloitte paper that says that 92% of blockchain projects failed, because you know what, that means 8% of them have succeeded, and that's pretty good startup rate for a technology, for business, or for a market, right? So if 8% are winning, that's a great thing. But how do we get into scale from there? You've got to make it fit things that people understand better. Things like the whole distributed, decentralized nature. Eventual consistency is a big deal. We all kind of know about eventual consistency. We know that we can pick a consensus mechanism that is sort of better or worse at reaching finality faster or slower or whatever. We can build protocols and we can deal with the idea that a transaction might be confirmed 1 minute and rolled back the next. But businesses cannot deal with that kind of thing. It doesn't make sense. You can't run your life, you can't pay employees' salaries on that kind of slightly quantum uncertain basis. So all of these things that are actually so advantageous, so great, that bring us a whole amount of opportunity in blockchain type systems are anathema to the way that most software and processes work in industry. There's all the spidery key management that shows up. Enterprises have a hard enough time dealing with simple encryption, simple SSL certificates. By the time you get into defining relationships between lots of nodes, lots of bits of software, lots of individuals versus organizations and so on, and the strength and power of those keys, and how many places they're in, and how many different ways there are to protect them and manage them, that's a really difficult thing for people to get their heads around. Just about after 35 years of dealing with this stuff in PKI and so on, we often see large enterprises having a key management department, or at least key management specialists who work for the IT department, or the risk, or the PKI guy, whoever it might be. They then instantly look at this thing and they say, well, so you bring it into my key management system then, put it into my, whatever, Talus box. And we say, you can't, because it doesn't work that way. Again, it's an unfamiliar thing. It scares them, it worries them, it doesn't fit the mold of their processes and so on, and so it's difficult to get through. And then, of course, there's all of the sort of this idea of governance, something that I think is really important and a little bit neglected in decentralized technologies and frameworks and things in general, is that we've kind of had that hype cycle of the last 2 or 3 years of saying blockchain is magic and it brings trust automatically and everything's kind of perfect. If you just turn it on, then nobody will ever be able to cheat again. And of course, that's not true, because you've got all of this sort of governance about who can join, who can't join a network. And even if people understand that you've got governance for things like rolling back transactions or for joining or for backing up something that theoretically shouldn't be backed up, even if they kind of understand that, it gets very difficult to convince them that actually you have to play in a world where there's no black or white choices. If you've got a 6-person consortium and one of them doesn't like somebody, they're used to working in a world where they can just kick them out, or they can rip up the contract, or they can do something else, because it doesn't work. If you've bought into a consortium or decentralized application, you've got to play by the rules of a group of other people. And all of these things, we use a lot of the same words, but they mean different things. And this confusion and this sort of mismatch also applies internally. So again, this is supposed to be the technical track, so I want to talk a bit about technical businesses. I run a team of engineers. I build a technical product. I sell B2B to technical buyers. In order to do that, I have to be able to hire staff. And in order to be able to hire staff, I need to be able to sort of advertise for skills that actually exist and to find people who have done stuff before. I can't hire everybody straight out of college because they're enthusiastic, because that doesn't lead to high-quality enterprise software. And so being able to have good choices of familiar architectures and coding languages is important. It doesn't matter which one's the best one. It matters which one's the best one with the most coders available who will actually work for me in some sense. And if somebody leaves, how do I replace them? I can't have somebody who invented their own language being the cornerstone of my business, because my shareholders wouldn't think that's very smart. So you've got a whole load of considerations to make on the code side, whole load of considerations to make on the jargon side. And of course, when you're building stuff that's so brand new, so unfamiliar, so uncharted, you also need a really good community of people to work with and to deal with. The basic way that most people solve their problems today, or at least the first thing they try, is they Google and they click on the first thing that has Stack Exchange in the URL. That's how you solve problems today. If you pick something that's too obscure, you won't have that get out, and you'll suddenly find that a sort of half-day bug costs you 6 months. And if you're costing 6 months searching through for some kind of issue that you've got in an underlying piece of utility code, again, that's something that's going to make your shareholders quite mad at you for picking that kind of thing. So we've got a whole load of business, customer market issues, which are somewhat technical in nature, because the reason they come up is because of the nature of the technology. And we've also got internal operational problems, which are very technical in nature, which is how do we actually have enough people to build enough stuff to sufficient quality that it will actually sell? This isn't about POCs. This isn't about science experiments. It's not about having a cool thing in the lab that draws a graph at the end to tell you how good something is. This is about actually selling something to somebody for real money and having them not send it back. So our use case, just to run through it pretty quickly, our business case for using blockchain is that we have a system which essentially tells everybody in a supply chain when who did what to a thing. When you get into use cases like IoT or connected infrastructure, you will find that it's much more complicated than sort of Patch Tuesday for IT in the enterprise. You've got lots of people who have lots of legitimate interest in this thing. It's physical, so it has to exist in exactly one place. And by and large, they tend to have more serious consequences if they go wrong. You know, if you have a blast furnace, or if you have a centrifuge or anything like that, or a train, if somebody does the wrong thing at the wrong moment, you can actually end up on Capitol Hill. You can end up with a big lawsuit. You can end up having arguments with your insurance company. And a lot of that comes down to questions of how well did we manage this asset that we've got? And that's not just a matter of keeping your own records, because if you run anything of any size, you've got contract manufacturers doing stuff, you've got contract engineering who are maintaining the stuff, you've got suppliers who actually write the code, and then you've probably got a third party, or at least an internal separate QA function, who's looking at things like safety certification or type approvals to say, you know, I'm not going to install version 3 on this thing right now until the properly competent person has signed it off and said that that's a good idea. And even when he signed it off and said it's a good idea, I'm not going to upgrade my baggage carousel right now because it's running and there's a guy inside it who's dealing with, you know, oiling the chains and stuff. And if I stop it or restart it while he's inside, I'm going to be in trouble. So all this kind of stuff is a collaboration problem. It's an information sharing problem. It's essentially a supply chain of continuous maintenance information, and that's what blockchains are good for. So this is what we do. Allow people to, you know, share all of this stuff and cover their risk. So the other side, once you've sort of got the information in, you need to have a reason for everybody to play, and the reason why they play better with a decentralized system than with a simple, centralized database or a SaaS or whatever else, is that nobody knows in advance what's going to go wrong. Nobody knows what's going to explode or what's going to catch fire or what's going to suddenly, shut down and put New York without lights for 6 hours or whatever. And so they're all looking to cover their own risk, just as much as the owner of the asset wants to make sure that it's looked after properly and doesn't break down. The people doing the maintenance need to cover their risk and make sure that if it does go wrong, they're not left holding the can or paying out, or it's their insurance that gets hammered to do it. So everybody gets to play this kind of mutually distrustful, mutually trustful game. And hopefully, if everybody does the right thing, nothing goes wrong, everybody's happy. But if it does, you save an awful lot of money and time in finding out what went wrong, root causing it, fixing it, and making sure it doesn't happen again. And that's the essence of distributed ledgers and blockchain there. I've got more things because I know the slides are going to be published, but I think you all kind of get that, right? This is a collaborative system where people who currently have a really hard time sharing information, making sure that information is complete and making sure that information is trustworthy, can now suddenly come together and ask really simple questions like, what the hell happened in Idaho? You can see that Bill updated the PLCs yesterday. You can then ask, why did he think that was a good idea? And now you know what to do, rather than ending up in court and arguing about the meaning of true time or aligning two different siloed proprietary log records or whatever it might be. So that's our use case. And I wanted to highlight that mainly because we are not a blockchain company. We are absolutely fundamentally a cybersecurity GRC company. We just happen to think that a decentralized application and a collaborative platform is the best way to achieve that. So, decisions. What do we want to do with our DLT? Where are we gonna get one from? So I always like this. It's a simple thing. But when people ask what's the best one, what's the best blockchain, should we do Corda or Hyperledger, even to lump Hyperledger into a simple thing. The answer to what's the best vehicle is where are you going? The ninja-looking thing in the middle is probably best for a commute if you're single, but it's not great if you're taking the kids to soccer practice or having a midlife crisis on the end there. So which one do we choose? Which is better? So we actually did, I fuzzed this out partly because the information's kind of old, and partly because we don't want to offend people with the pink squares on sort of in eternity on the camera, but I am happy to sort of discuss these things with folks afterwards if you genuinely want to know. Back in something like February of last year, so about a year ago when we started this development, we went and did a fairly good in-depth assessment check of the various options available to us and did some pros and cons based on a few key principles that we had. So thinking back to those internal technical pressures of, can I hire people who can write this code? Can I have a hope of convincing my customer? So this is going to be something that's familiar enough that they could at least hire a consultant to analyze my smart contracts and things like that. And we decided at some point to standardize on Solidity, or at least EVM. I really, there's this kind of shortcut to some of these things. I really like Sawtooth. I like the design of Sawtooth. I think it's very clean because of our use case for sort of mutual distrust, but also having this kind of quick collaborative platform. It's really important to make sure that all nodes are equal, so you have a completely fair, plain peer network. And I didn't want to mess around with, Fabric has a lot of really lovely features if you need that level of power and delegation, representation, differentiation, and so on. But I didn't want those to mess up my model because I didn't really need them. Even things like channels, we don't need channels because we made a policy of doing confidentiality and zero knowledge and kind of stuff at the data level. So we're working out those relationships in the data elements themselves, partly because we deal with data that's bloody huge and it doesn't go on the chain, so you had to do that off chain anyway. We might as well keep that going. So lots of reasons why we made these choices. and went down. So we've got things like EVM compatibility is on there because we decided to do that because Solidity is accessible, because you've got a whole ton of open source tooling that works, and because there's a small but viable industry of people out there who could actually write code for you or write code for our customers to work. So we went and did a bunch of things, and we made our choice, and our choice was, at the time, Sawtooth. So then we got into a bit of a period of development, and there's a guy called Howard Marks. I don't know if anybody knows this. It's actually an investment book. It's a VC book called The Most Important Thing, Uncommon Sense for the Thoughtful Investor. And it's full of little nuggets. I've never actually read the book. It's one of those things where you just pick up quotes and put them on PowerPoint slides, but it's full of quotes that are very quotable. And one of them is this. I just thought it was funny, so I put it up. But actually, the experience has been great, but we certainly have learned a lot. Actually, the thing that's most interesting that everybody knows, this quote has shown up in thousands of PowerPoint slides, and I suspect didn't even credit Howard Marks, is that being too far ahead of your time is indistinguishable from being wrong. And so what started to happen was that there's always a worry that you're too far ahead of your time in using decentralized applications, blockchain, whatever at all. This is a young industry. It's kind of new. I think everybody in this room, hopefully a lot of people on the far side of that camera too, really believe that the end game is the true end game. We know that we're heading for a data-driven economy. We know that we're going for fairness and transparency in transactions, and that trust is no longer based on a sort of strong, crunchy lockbox CIA model of just encrypting stuff and hoping like hell, but rather having a more sophisticated notion of transparency and traceability, equitability, and resiliency as being a much more important thing than just trying to hide everything. Even so, it's early in that journey, who knows. But it turned out that our timing in developing this product was also slightly exciting, because between starting the development and now, where last week I was in San Francisco actually launching the GA of the product, so we're partnered with Microsoft, we're partnered with Ping Identity, we've got the thing live. You can just buy it with one click if you want to pay our standard terms. So we had to get to that point of going live, and between the start and the live date, we had a bunch of disturbance in Hyperledger as a whole. All of the Ethereum alliance type stuff like Besu came in between that time, would have changed the mathematics, changed the dynamics, has other opportunities and things that maybe if it had been there before, we would have started there, maybe not, who knows. Sawtooth also has been through a period of stability, which is good, going up to 1.2, but it also had a period of disturbance because of upgrading all the stuff from Python to Rust, and finding a bunch of bugs in there that will never be fixed because they were in the Python version, but waiting for Rust to be fixed and ported across also takes too long. And of course, again, good developments, but just a little bit slow for our use cases. Things like the questions over which are the more popular or supported consensus mechanisms, because we went from having everything in Poet, and then Poet kind of almost got upgraded, but not really, and then we've got PBFT, and PBFT was kind of working, but then was incompatible with 1.15, which was a problem because we couldn't wait for 1.2, and then SBFT showed up as an option, and that might be great at some point, but it's not quite in there. So I'm super confident that at some point this will all be good. And there are folks like blockchain technology partners in the audience here who have gone through that mill and actually made the thing stable and working. So I'm quite confident that we will get to a point where it's good. But for my timelines and my use, it just wasn't ready. So we had to do something else. And as a startup who actually has customers and shareholders and investors to deal with, we had to come up with a plan B. So what we actually did, and this is where we get to, this was my quandary, how deep do I go? And this is where I decided to stop. I'm a kind of a mid-zoom on the architecture stack. And this is also the place where I'm happy to just sort of stop and take questions. But what we decided to do was essentially make a pluggable blockchain layer. So what I've called network abstraction here is kind of the punchline of this whole thing. But also to make the application and the user experience, the product itself, isolated from any of this disturbance or changes in the blockchain network. So an awful lot of what we've got here actually isn't blockchain-y at all, because it turns out that's what people will buy. So the first thing that we did was that we decided to make the primary interface to identity be not our problem. So we've got a whole bunch of stuff. You know, my plans, some of the work that my team is working on, some of the things we've sort of prototyped, go all in the direction of other talks we've had this week for things like self-sovereign identity, for things like derived machine identities and things like that. We've got loads of zero-knowledge proofs and stuff all over the show. But for right now, what a company will actually accept to use is something like Azure AD or Kerberos directory, something like that. And so, you know, rather than us inventing our own ID system, which then requires a whole bunch of vetting and people checking it and going through, what we have to realize is that enterprise ID is a very, very serious business. The reason why people take it so seriously and have lots of forms to give somebody a two-factor token, or you have really, you know, harsh HR-related things for offboarding somebody when they leave or when they do something bad, is because giving somebody access to an enterprise identity essentially allows them to act as that business. That legal entity is being signed up to all kinds of obligations or being implicated in all kinds of actions by the actions of that employee. And so having not only the technical challenge of explaining to people how blockchain IDs work, or even how claims and credentials out of a zero-knowledge or self-sovereign system work into there, is as of nothing compared to then convincing the procurement department or the legal department that they will accept that as an on-behalf liability or obligation for one of their people. I think that's an important thing to remember. Again, in Hyperledger, this is enterprise blockchain. You've got to work with enterprises. And an enterprise, if nothing else, I guess we're in America, so I could call it a person, but it's not a person. An enterprise is a legal entity, first, foremost, and only. And that's what you've got to deal with. So we decided just not to have any ID, offload it. And actually what that means is that in this organization over here, who's part of the network, they can use one set of rules and principles and two-factor IDs and a directory and whatever it is that they have that they've decided that they trust and that their legal department is happy to deal with. And this organization over here, although they're on the same network and they're communicating and they're sharing information, they can have a completely different set of policies, different set of IDs, different set of two-factor tokens, but they can play together because we've abstracted that thing away. Then, I think this is becoming common. When we started a year or so ago, I think it was still a little bit of a taboo to do things like this, but I think most people have realized that you have to have a bit of a hybrid architecture these days. So the next thing that we did was to have a sort of, it's a lot more complicated than this. We've got some kind of cool tweaks in here, but was to make sure that the first thing that applications and so on deal with is actually an ordinary looking web access layer. And this allows all of the usual stuff like familiar programming. But most of all, if you see, we've got things like the handheld device that maintenance guys walk around with. If you're doing things like field inspections, quite often what we encounter is a mobile app, and the guy will go along, he'll have his works list, and he'll just tick a thing off, take a photo of the device he's just polished, and send it up to the cloud to be done. That's a piece of code which is written once, probably by a contractor or a systems integrator, and never ever touched again. And so you've got to make damn sure that when you land a customer and you integrate your system with that piece of code is always going to work, at least for the next like 3 to 5 years. And so if you're dealing with the really fast-moving world like blockchains, like protocols, like wallet standards, like, if anything from the smart contracts start to pollute your public interface or the software code integrations, you're dead. You just cannot sustain that kind of thing in a wide-scale implementation. And that's the same kind of thing with if you've got actual physical devices. If we're integrating into things like electric vehicle chargers, we can't just go and keep on updating that thing and retype approving it every time the blockchain stuff changes. So, long way of saying make a nice RPC interface, but it's more than that because you've got to think really carefully about the data typing. You've got to think really carefully about addressing, because otherwise you'll quickly find that artifacts of the DLT will start to leach up into your REST interface, and you'll still have problems. And then the last thing that we do for sort of robustness and so on is to build all of the functions first and foremost as microservices. So we still don't go straight from the RPC into the chain. We have full, nice, very capable, mostly Golang microservices that handle the requests. The reason we have to do things like this is partly because we've got this sort of big Jitsuin bubble in the middle. Being a hybrid architecture, blockchain nodes, access to the entire ledger, custody of the important keys and the participant data and all of that belongs to each of the participants. So they have full control over that piece of it, the record and their ability to recover things and dispute things and prove truth and so on. But we're not dealing with very, very simple transactions. We tokenize assets. Again, if you look at this guy up here, something like a PLC, we tokenize those assets and store their entire life history. We store every time somebody tightens up a nut, or every time somebody issues a work order, or every time you get a vulnerability alert. Some of that data is very, very large, and as we know, you don't store very, very large data on a blockchain. And so we have a whole bunch of SaaS services which are shared by the value chain just for doing things like deduping large files and storing the big stuff and doing quick lookups and so on, things like that. So one of the things we can do is simply deal with that. One of the other things you have to do is that having a microservices interface here allows you to have much, much better relationship with your code and human customers. Because thinking back again, I mentioned eventual consistency. Again, this isn't new. Everybody in this room knows what eventual consistency is here. Everybody knows that you have to wait and you have to keep pressing refresh and you have to look and search and accept that your thing isn't found by hash for several minutes, whatever it might be. That's no good if you're an enterprise UI, or it's no good if you're a guy, this poor guy who's in the field who's got maintenance jobs to do. He's judged on yield. And his bosses know that if he works at an appropriate work rate, he can visit 9 devices in a day and get through that number of maintenance calls in a day. And so if he has to sit and wait and stand and just stare at his phone, waiting for transactions to complete, and then waiting to make sure they haven't been rolled back, that's not only annoying, it's actually a business deficit and it won't fly. So we get to do a whole bunch of sort of risk assessment and making sure that you've got no obvious problems that are definitely going to fail. We run a kind of simulation of the transaction just to make sure that there's no bad objects and stuff like that. So you can get a very quick, very high quality, usable response back before you submit yourself to the wiles of the DLT. Down at the bottom, smart contracts. We all know what smart contracts do. We've got our source of truth, and it is very important that the source of truth is the ledger still in the end. Everything that we stand by, that we have analysis on things like, if Bill swears blind that he definitely polished the thing, and Bert swears blind that the thing is not polished, and that's why it stopped moving. How do we work out which is true? Well, that's absolutely down on the ledger level. It's not anything to do with the top web stuff. And so to bring those together, what we needed to do was to make this abstraction layer. And I don't know how many of you guys actually have built whole systems, or whether you kind of start at this level. If you start at this level, I guess the choices thing won't make a huge amount of sense. You might not realize why. But for us, what we needed to do was to be able to build this whole system and have people interacting and have maintenance teams submitting stuff and have security teams submitting patches and having owner organizations doing things like submitting regulatory compliance reports and stuff like that. So that's what this system does. But we also needed to make sure that this part was going to work no matter what the turbulence and the changes and the sort of cutting edge stuff we were dealing with. So what we ended up doing for this was to make a few very hard choices that gave us a number of very strong options for implementing our ledger underneath everything else that was going on. So not only did it give us choice, but it also unblocked the development of most of the SaaS service while we worked out which technology could work. I was spending fairly long hours trying to fix bugs in Seth, for example, while the guys were able to write the rest of the stuff, while one of my other guys was working in Burrow on a plan B. So this was a nice thing. And the choices that we made in the end were fairly few. We stuck with the idea of going EVM. Again, I like transaction families in Sawtooth. And if I was doing a home project, or if it were less critical, or if it was smaller, I probably would just do a native one. Kind of like DAML. I'm a big fan of formal stuff. So stronger languages are better in my view personally, but for a business, we had to stick with something that fulfilled my original plans. So EVM, initially Solidity, effectively. And because we'd made that choice, we also were able to standardize on RLP for serializing our objects for points where you really can't avoid things bleeding through the layers. We did that. And we had to make sure that token addressability was consistent, and so we stuck with a particular tokenization form in EVM for our object IDs, which go all the way right up to here. If you want to access a machine token, see what all happened to this particular thing, that bleeds up through that stack. But that was all we had to do. And everything else, we then had total freedom to switch out the things south of the south of this guy here. So it gave us an awful lot of choice just with those three very simple things that we did. So what made that actually possible? Strong encapsulation. I mean, these two, I'll put them up quickly because they're kind of obvious. If you've ever done a CS course, you'll know that this is right. But actually, it's worth repeating because I still don't see this practiced very often. If you look at a lot of the examples, even if you go to the GitHub repositories for Hyperledger, or if you look at a lot of the examples outside of Hyperledger, you go to any of the other guys. I won't name them here just because I'm guest of the Linux Foundation. But there are a couple of other big organizations that do just decentralized apps, and they have a bunch of examples. And actually, this doesn't tend to happen. You tend to end up with slightly messy cross-cutting concepts in smart contracts and things. You tend to end up with having tokens that are used for a bit too much, or functions that have side effects, which you don't really want. It's really important to make sure that your functions are as small as possible, not only because of things like security, not only because of things like upgradability and durability, but also because if you find that a tiny piece of your puzzle doesn't work, the less of it you have to switch out at short notice, the better. So these actually are fairly important points to make, even though they should seem obvious. But the biggest thing is this. I hear a lot of people talking about interoperability in blockchain. I was on a panel about a year ago in London, and somebody said, what's the most important thing about interoperability in blockchain? You have to kind of eat the same dog food as the industry as a whole. If we think that we're building systems and plumbing and infrastructure for a data-driven future where everything is just sort of passed around and virtualized and tokenized, then you have to make sure that your interoperability plan is at that data level. You have to make sure that if you've got tokens, that token format is expressible and consumable in multiple different technology stacks, from the kind of at least the middle, if not the top, right down to the bottom. Otherwise, you're stuffed. If you've got attributes on those tokens, if you want to actually be manipulating But traditional meta and also real data, you've got to make sure that those are expressible in all of the frameworks. It's no good having nested complex objects if you then go into a framework that doesn't support nested complex objects. You just end up having a real nightmare. So again, seems like an obvious point, but actually it's really important to knuckle down, look at what's really valuable to your business case, design a very strong data typing, data format design, and then shove that back up into what you're using. But indeed, it's not only 3 rules, it's 4, definitely a 4th rule. It's very easy in all of this. By the time most of your team have written loads of Golang and somebody's just had the great epiphany of learning how gRPC works and how absolutely wonderful it is to just sort of write 3 lines of meta code and have everything spat out for you, to lose sight of what you're doing with the decentralization, to tread on the toes of the blockchain and end up with essentially a really slow database. That's not what you want to do. You've got to remember every time that the objects on the ledger are true. And if the ledger somehow disagrees with your data store has to be blown away and rebuilt, because that's, you've clearly made a mistake. You've got to make sure that all of the state transitions and everything you're promising are done through smart contracts with the correct keys that are separate for every node. Otherwise, what you've got is a centralized system, and that's also not what you wanted. One of the big reasons why we like to keep a DLT for our own purposes. We're a small company. We're dealing with potentially important and difficult situations. If somebody doesn't patch a device, there's rules and regulations now in quite a lot of countries around the world that basically say if you're doing stuff like power generation or water cleaning or public transit, and you put computers or IoT or connected infrastructure or any kind of intelligence into your devices, you better make damn sure that those devices are kept up to date, because if you let them lapse and you get hacked, and heaven forfend any of you doesn't know this, but if you want to know the kind of consequences, just search for ransomware in your browser, and you will find countless examples of infrastructure that was left unpatched for too long and got broken. These regulations say if you leave it unpatched for too long, you are negligent and you will get fined. Or if you don't get fined, you might even lose your operating license. That's a big, big problem. I don't want to be in the suspicion loop for messing with that kind of data. I don't want anybody to think that I can press a big button and shred some incriminating evidence or hide access to someone who's trying to build a defense case. We just want to make a fair system where everybody plays by the rules, everybody does their job, and hopefully everything's fine. But if it isn't, you get to find out the truth quickly. And there's no way that we want to be in the middle of any kind of shredding scandal. So what we managed to build with that, this guy's kind of fun. This was never intended to be a product, but we had to prototype things, we have to show things. So we've got this kind of arcade machine, jobby that demonstrates the product in, I say 1 box, it's actually 2 boxes because we've got the laptop here, but demonstrates the whole thing working, where you can do things like enforcing patch operations. So if you get a hacker screws with your traffic lights, for example, you can run using smart contracts through that entire process of raising the alarm, which means a variety of things, and then issuing a patch, installing the patch, getting it done, eventually getting everything back in working order, and then having a full service history showing that. So you get a kind of automatic, all-party shared compliance report out of the product. And that's using a lot of the same code that the main product does. But because it's all self-controlled and it's on Raspberry Pi and stuff, we did all that on Burrow, which is kind of nice. From there, we built the actual SaaS service. So Archivist is it's a SaaS, as I say. If you want to go to Microsoft Marketplace and click a button, we have a sort of standard pricing plan. You can just buy one, and you get a URL and a login. Archivist is a SaaS which kind of does the same sort of stuff, but just much bigger for real devices. And we won't be able to see this, but I'm happy to show you guys afterwards. Each of those events that happen, things like a vulnerability alert or a patch or whatever, all of that information in one place, shown there. And what you would be able to see on a bigger screen is that we have the transaction IDs and the token IDs are all linked there. So the experience that the user gets is very enterprisey standard. Oh, there we go. I did put one in there. The enterprise user has an ordinary experience. They see a SaaS service. They deal with interesting, large, human-readable data elements. But at any point, if you want to double check and make sure that everybody's seeing the same thing, you've got all that data there just in case. That's another important lesson learned from a lot of sort of POCs and conversations and trials and stuff. If you hide the blockchain completely, nobody gets it, and it's kind of pointless. But if you make it very prominent and you put things like transaction IDs as the first element in a list, everybody's lost and they wonder what the hell you're talking about. So having that ability to keep it there when it's needed, but not like shove it in people's faces, that turns out to be a good thing to do, and that's a thing we were able to build with this flexible architecture. So we actually managed to transition from Burrow to Sawtooth. As I say, fingers crossed, maybe we'll come back to it at some point, but we had to transition off Sawtooth for now while we're doing the go live. So our live networks are actually running on Quorum right now, but for space and speed reasons and all sorts of other things, cost even. I'm aware there's another session next door which is about running Fabric on Microsoft Azure. So we run on Azure, and we have to pay for all the space and the computing time and the networks and the Kubernetes clusters and stuff we use. We actually do our QA, our smoke QA tests on Ganesh because it's really simple, it's small, runs quick, and everything else. And most importantly, we've got the opportunity to flex again. So as the market improves, as things get better or worse, as we get more sort of serviced blockchain options that might be worth using, we're able to do that without having to rewrite very large parts of our stack. We don't present our customers with the blockchain thing as the entire full product. We present them with a thing that's underpinned by blockchain, and what that means is that we're able to go and keep the however many $1 million of investment we've already spent and just swap out for something better underneath, which of course is what all SaaS services are supposed to be able to do. So that's what we built. It also, I made the point earlier, but it means we can publish our docs on the internet, and people can write code today that will continue to work in a year's time or so. That's also super important. And that was it. That was what we did. So as I said, technical questions come in the question section, but any other questions too? Duncan.
So we introduced multiple blockchain simply, not simply because, as you said yourself, the vast majority of the data is not on or near a chain, therefore if you're actually operating at a facility level, gives you more portability than you might otherwise get.
Yeah, so the question was, did we build the pluggable level because it gives us more, two things. So because it gives us more flexibility than we would otherwise have had, and also because a lot of the data actually isn't going through contracts. Yes and no. So we did it first and foremost because we had to. We had a solution that wasn't working, and my job is to make things work. So we did that, and with a bit of thinking. One of my guys is doing a PhD in blockchain at Cambridge, and we're all kind of old. It's a startup, but I'm nearly 41 now, and I'm the youngest, right? So we've all got that kind of systems engineering, aerospace, security experience to step back and take a quick look at a problem when it arises. And we just sort of decided that we're going to have to change anyway. And actually, the effort of making something good and flexible and retaining our business choices in the future was not much more than just making a hard switch. So that was kind of why we did it. But indeed, yeah, those choices that we layered into that, going with something like Solidity, exactly, yes, because it gives us the flexibility of what test frameworks to use. It gives us the flexibility on libraries and things that we can draw in, and standards and everything else. With respect to the data, there's very little data that we run through the system which isn't somehow touched, but it's the usual thing. So a lot of the time, if you're doing something like a maintenance report, you'll have a 3 or 4 page scanned PDF, and we don't put that in, but we do hash it, and it is part of the event that runs through the contract. So there's a lot of linkability, but indeed, yeah, we didn't need to think too hard about how to deal with very large or very high throughput transaction volumes because we deal with that in the higher layer. And the other thing I missed off, of course, which is massively important, was all of the DevOps. So, in that sort of very oversimplified architecture diagram, all of the key storage, key distribution, backup recovery, the Kubernetes clusters that we run, the system monitoring, the health probes, that's big, right? But it just wasn't relevant to this. Kevin.
So, I'm kind of curious about the large object.
Yeah.
Are the contracts actually accessing that directly, so it's set up as some kind of a local interface? Is that how it is?
Currently, no. So currently, it's kind of it's just stuffed straight down. We've got plans to distribute that piece as well. So right now, that's just part of the SaaS, and we run that. But that's really for practical reasons. It's just because distributing that piece requires a lot more infrastructure in the customer's tenants. It requires a lot more networking and stuff that is just not worth taking that operational risk. But so eventually it will be what you said. The question, by the way, sorry for the tape. The question was about the sort of large object store and the relationships between PDFs and photographs and stuff and what's on the chain. Yeah. So for right now, they're given a hash as the object reference. And then that persists, and that's part of the smart contracts. And they do link, because if you get things like approved configurations or firmware images and stuff like that, they may show up in multiple stages as you're verifying that you're actually doing the same thing. So there's a lot of linkability, but ultimately the contracts right now don't actually know what was inside. We don't have on-chain validation of firmware headers, for example.
It's interesting. I love the whole concept. But it seems like that's something that would be subject to the same sort of have an area of abstraction or ways in case you want to do something different.
Yeah, for sure. I think again, as so. Yeah, and Kevin said he loves it. That's what I'm taking from that. Loves it, but isn't the big object store a thing that should also be abstracted away? So yes, absolutely, it should also be distributed. That's actually an area where we have a lot more of our sort of data level security as well, because when you've got competitors on chain, if you've got right at the kind of the top of the tree, you've got the operator, or you've got the city, or you've got the safety authority, whoever that's actually running this thing and is legally liable for the big problems like train crashes or fires or whatever it might be. But underneath that, of course, you've got lots of suppliers who really shouldn't be seeing each other's invoices. They really shouldn't be able to know who's performing poorly on cybersecurity SLAs and things like that. So that store has a lot of the message level security pieces in it, which again makes it a little bit harder to split out in the beginning. But architecturally, philosophically, yeah, the plan is to split that out too and allow sharding so that people hold on, only the right pairs or whatever of people hold on to even encrypted copies of that stuff. It'll come. But, yeah. So anything else, or are we going to see Brian? Yeah, okay, right. Well, so Uncle Brian it is. So thanks very much. I did plan to do a demo, but demo gods are never kind to me, so I didn't do that. But we have a live system. If anybody's interested, I can run one. Not at the party tonight, but maybe tomorrow. Okay, cheers guys.